Today, we are going to explore the different types of computer networks. We will classify them based on their geographical coverage and scale. We will look at personal area networks, local area networks, metropolitan area networks, and wide area networks. Understanding these network types is crucial in today's interconnected world. Let's start with the personal area network, or PAN. This is a network of personal devices that are connected within a small range, typically about 10 meters. It is usually used by a single person. A personal area network is a network covering an area of around 10 meters. It is typically used by a single individual. Some of the characteristics of a PAN are: it has a range of up to 10 meters. The technologies it uses are Bluetooth, near-field communication or NFC, and infrared. These connections can be wireless or wired, using universal serial bus or USB. Common devices in a PAN include smartphones, laptops, and wearable devices. Security in a PAN is generally personal and has limited access. Next, let's discuss the local area network, or LAN. This is a network that connects computers and other devices in a limited area, such as a home, an office building, or a campus. A local area network is a network connecting devices within a limited area such as homes, offices, or campuses. Its characteristics are: it can cover a range of up to 1 kilometer. The technologies typically used are Ethernet and wireless fidelity or Wi-Fi. Data speeds can range from 100 megabits per second to 10 gigabits per second. Local area networks are commonly used in offices, schools, and homes. The arrangement of devices can follow a star, bus, or ring topology. Security is usually controlled by the organization that owns the network. Now let's explore the Metropolitan Area Network, or MAN. This is a network that spans a city or a large campus. It connects multiple local area networks within a metropolitan area. A metropolitan area network covers a larger area such as a city. Its characteristics include a range of 5 to 50 kilometers. The technologies it uses are usually fiber optic cables and microwave connections. Data speeds range from 100 megabits per second to 10 gigabits per second. Metropolitan area networks are used in city networks and university campuses. Ownership can be by public or private organizations. The arrangement of devices can follow a ring, mesh, or star topology. Finally, we will discuss the Wide Area Network, or WAN. This is a network that spans large geographical areas, connecting multiple local area networks and metropolitan area networks across countries or even continents. A wide area network spans across very large geographical areas and connect networks across countries and continents. It has an unlimited range, essentially global. The technologies used include fiber optic cables, satellite connections, and cellular technologies. Data speeds are variable, ranging from 10 megabits per second to over 100 gigabits per second. A prime example of a wide area network is the Internet. These are typically owned by Internet service providers, or ISPs, governments, and large corporations. The cost for implementation and maintenance is high. Here is a comparison of the different network types we've discussed. Starting with the personal area network, it covers a geographic range of up to 10 meters with speeds ranging from 1 to 3 megabits per second using Bluetooth, and up to 480 megabits per second using universal serial bus or USB. It uses technologies like Bluetooth, near-field communication or NFC, infrared, and universal serial bus or USB, and is typically used for connecting personal devices and wearables. The local area network covers up to 1 kilometer, with speeds from 100 megabits per second to 10 gigabits per second. It uses Ethernet and wireless fidelity or Wi-Fi, and is used in offices, schools, and home networks. The Metropolitan Area Network covers 5 to 50 kilometers with speeds from 100 megabits per second to 10 gigabits per second. It uses fiber optic and microwave technologies, typically found in city networks and university campuses. Lastly, the Wide Area Network has an unlimited global range with speeds of 10 megabits per second to over 100 gigabits per second. It uses fiber optic, satellite, and cellular technologies, and is used for the Internet and multinational corporations. Each network type serves specific needs based on its geographical coverage, speed requirements, and use cases. Network topologies refer to the physical or logical arrangement of nodes in a network. This arrangement affects the network's reliability, how well it can grow or scale, and its overall performance. Let's examine some common network topologies. First, we have the star topology. In this setup, all devices connect to a central hub or switch. This design is easy to install and manage, and if one device fails, it does not affect the others on the network. Next, we have the bus topology, where all devices connect to a single cable, also known as a backbone. This is simple and inexpensive to set up. However, if the main cable fails, the entire network is affected. Lastly, the ring topology is where each device connects to exactly two other devices, creating a ring. Data travels in one direction around the ring. A failure in one device can disrupt the entire network. Let's look at the future of computer networks. Several emerging technologies and trends are shaping the evolution of network infrastructure. One key trend is 5G generation or 5G and beyond. This technology offers ultra-high speeds, low latency, and massive device connectivity, enabling new applications in Internet of Things or IoT, autonomous vehicles, and smart cities. Another trend is edge computing. This involves processing data closer to where it is generated, reducing latency and bandwidth usage. This improves response times for critical applications. Zero Trust security is also gaining prominence. It moves beyond traditional perimeter-based security to verify every user and device, attempting to access network resources, regardless of their location. Artificial intelligence or AI-driven networks are emerging. These self-optimizing networks use machine learning to predict issues, automate management, and adapt to changing conditions in real time. Satellite internet is also expanding. Low Earth orbit, or LEO, satellite constellations are providing global high-speed internet access to previously underserved regions. Finally, network virtualization is transforming networks. Software-defined networking, or SDN, and network function virtualization, or NFV, are creating more flexible and programmable network infrastructures. As networks continue to evolve, the lines between traditional network types such as personal area networks or PANs, local area networks or LANs, metropolitan area networks or MANs, and wide area networks or WANs are becoming increasingly blurred, emphasizing seamless connectivity and intelligent management across all scales. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.